Hello guys, welcome back to Physics Vedika. So today we are going to cover one more interesting concept that's nothing but average speed and average velocity. So previously we have seen what is distance and displacement. Now average speed, right? Let's say if you are moving from your school to your home, let's say you're moving in a bike or you're moving in a car. So if I say the car has an average speed of 30 km per hour, right? 30 km per hour. And if I say the car has an average speed of 90 km per hour, what is the difference you are going to observe here? You can easily understand. If you are moved through an average speed of 90 km per hour, you can see how much rapidly you are moving, right? But when you say your average speed is 30 km per hour, you can see how smoothly you are moving, right? So you can easily understand the average speed is giving you how rapidly an object is moving. As I said, the car is moving with 30 km per hour. The meaning is, every time the car is maintaining 30 km per hour? No, need not be, right? Sometimes it's going to have a speed of 60 km per hour. Sometimes it's going to have a speed of 20 km per hour. Sometimes if a speed breaker comes, it might go to a speed of 0 or 5 km per hour, right? It might stop also somewhere if it applies brakes. Average speed, you can measure it by finding total distance upon total time. Okay, so total distance upon total time gives you average speed. Okay, so let us look into some interesting numericals to understand the average speed. First question: an object travels 16 meters in 4 seconds and then another 16 meters in 2 seconds. What is the average speed of the object? So here what we can do, we know the object is traveling the first 16 meters in 4 seconds of time and the next 16 meters in 2 seconds of time. So it means it is taking more time here in the first portion and it's taking less time. It means it may travel with some different speed over here. It may travel with some different speed here. But what he is asking about average speed. So how to get average speed? So if we want to get average speed, what is the way? We need to know the total distance upon total time, right? So this is the only way. Then it means V average is equals to total distance. How much is the total distance is traveling here? 16 plus 16 divided by total time. Total time is 4 plus 2, that is 6 seconds. So it means it will be 32 by 6. So it will be approximately 5.33, right? It goes on, and you can see the distance is in meters and it is in seconds. So your answer will be 5.33 meter per second, right? So this is the average speed over here. Hope it's clear. Now let's look into the next question. The odometer of a car reads 2000 kilometers at the start of a trip and 2400 kilometers at the end of the trip. If the trip took 8 hours, calculate the average speed of the car in kilometer per hour and meter per second. So all of you, before look into the solution, stop the video for a moment and try this question. You already seen the solution of the first question, so try the second question and then look into the solution. Okay, hope you tried. Then look at the solution now. The odometer of a car reads 2000 kilometers at the start of a trip. So initially the reading is 2000 kilometers. Then the final reading is 2400 kilometers. Right? Reading initial and reading final. It means how much you travel here. So total distance would be 400 kilometers, of course. And what is the total time? Total time of journey is 8 hours. It's given clearly. So what is your average speed? Average speed will be total distance by total time, kilometer per hour, right? So that will be 50 kilometer per hour. Don't need to worry about how the car is traveling. The car might be traveling with different speeds during the entire journey, but if we just want to calculate the average speed, so we just need to find out the total distance by total time. Okay, so now how to convert this kilometer per hour into meter per second? Kilometer is 1000 meters and 1 hour is 60 into 60, so 3600 seconds, right? So it means 1 kilometer per hour equals to 1000 by 3600, so that will be 5 by 18, right? So just multiply by 5 by 18, you will get the average speed in meter per second, right? I am solving here. As you can see, average speed is going to be 50 into 5 by 18, right? It will be 250 by 18 meters per second, right? Now let's look at one more beautiful example about average speed. So run rate is something which gives you how much effectively the batsman has scored the runs, right? Or at what rate your match is going on. Okay, whether you are at a good situation or whether you are at a bad situation, you can easily understand by looking at the scoreboard, and that too by looking at the run rate. The idea of run rate I am giving here because how you measure average speed, the similar way you are actually measuring the run rate. So that's why I am giving this idea here. And when you calculate the average speed, as you know, the car might be having various speeds while it's traveling from one place to another place. Okay. Similarly, when you calculate the run rate, the different runs, the number of runs scored might be different in different overs. But when you look at the run rate, it's about the total runs upon total overs. Okay. So in between you may score 0 runs in some few overs, or you might have scored very well in few overs, but the run rate gives you the overall idea. Similar to the average speed, the car might be traveling at higher speed or at lower speed, but the average speed gives you the overall idea. Okay, so that's why I have given this example over here. So let us look at one application for average speed, means how you can use this concept in the numericals. We have already solved two simple numericals. Now to solve some good numericals, you need to understand how to apply this concept here, right? So as you can see, it's given that a body travels first half of the distance with speed v1 and the next half with speed v2. then the average speed of the total motion is given by 2v1 v2 by v1 plus v2. Actually, you can remember this as a formula, but I will tell you how you can derive this formula. Okay, right? Let us see. The body travels first half of the distance. It means, let's say total distance is s, then half of the distance means s by 2 with the speed of v1, and the next half of the distance with the speed of v2, and here it takes a time t1 and here it takes a time t2. So what we can write here is, generally we know that distance equals to speed into time. So what is time? Distance by speed, right? So by using this, what you can say about t1? So t1 will be s by 2 by v1. It means that is s by 2 v1, right? Similarly, what is t2? S by 2 v2, right? Then what I need average speed. So that average speed is going to be total distance by total time, right? So what is the total distance for the particle when it travels from here to here? The total distance is s by 2 plus s by 2, right? That will be s. And what is the total time? t1 plus t2. So what you are going to get is, what is t1? T1 will be s by 2 v1 and t2 is s by 2 v2. So that gives us, the s gets cancelled here, and you can take this, it has 1 by 2 you can take, so it will be 1 by v1 plus 1 by v2. So the 2 will go up, and this v1 v2, if you simplify, you will get it like this, 2 v1 v2 by v1 plus v2. That will be the average speed. Hope it's clear, right? A man walks at a speed of 6 km per hour for 1 kilometer and 8 km per hour for the next 1 kilometer. So what is his average speed for the walk of 2 km? See here, km per hour for 1 kilometer. So initially he is covering 1 kilometer journey and his speed is 6 km per hour. Hope you tried this, right? Then another 1 kilometer of journey and his speed is 8 km per hour. Okay, so it means how much time it takes here. It takes a time of t1 here. Here he takes a time of t2. Okay, we need the total distance. The total distance is 1 plus 1, 2 km, but we don't know the total time here. So how much time he is traveling, he is taking, we should know, right? So we know very well distance equals to speed into time if you are going with a uniform speed. Then what is the time in the first journey? That will be distance by speed. So that will be 1 divided by 6, right? Then your t2 will be 1 divided by 8, right? So total time will be 1 by 6 plus 1 by 8. So that will be 14 by 6 into 8. Okay, so you can write like this. So that will be 7 by 24. Okay, hours. Then comes to average speed. So average speed, what I do here, total distance. Total distance is how much? 1 plus 1, 2 kilometers. And total time is how much? 7 by 24 hours. So that will make it as 48 by 7 kilometer per hour. Okay, right? I think this physics Vedika is occupying some space. Okay, we'll try to remove it. No issues. Okay, so that's the average speed. I will explain once again. Listen. A man walks at a speed of 6 km per hour for 1 kilometer and 8 km per hour for the next 1 kilometer. So what is his average speed for the walk of 2 km? So in this case, initially 1 km per hour, 1 km he is traveling at a speed of 6 km per hour. Then later 1 km he is traveling at a speed of 8 kilometer per hour. So his speed is different in different time zones or different distances. So you have to find the total time. How will you find the total time? Initially 1 kilometer he traveled with speed of 6 kilometer per hour. So your T1 will be S by V, distance by speed. So that is 1 by 6. So that will be 1 by 6 hours. Then in the second case, the time journey will be T2. And in this case, what is T2? T2 will be distance is 1 and the speed is 8. So 1 by 8 hour. So what is the total time? 1 by 6 plus 1 by 8. That will be 7 by 24 hours. Right? Then what is the average speed of this particular man? Total distance by total time. What is the total distance? 1 plus 1. That is 2 kilometers. And what is the total time? Initially, he takes a time of 1 by 6 hour. Then he takes a time of 1 by 8 hour. So total time will be 1 by 6 plus 1 by 8. That will be 7 by 24 hour. So 7 by 24, if you substitute, this 24 will go up. It will make 48 upon 7 kilometer per hour. Is that okay? Right. This question you can just solve it by even applying the formula also. So that will be average speed is going to be 2v1 v2 by v1 plus v2. So based on this you can see it is 2 into 6 into 8 upon 6 plus 8. So the same answer you're going to get it here. 48 by 7 kilometer per hour. Hope it's clear. Do this question. A man has to cover a distance of 500 meter. He covers the first 250 meter in 3 minutes 20 seconds. He stops for 1 minute and then he covers the next 250 meters in 4 minutes. What is his average speed? Great. So as you can see, he has to cover total of 500 meters, right? So initially he covered 250 meter. Then he covered the remaining 250 meter. So in the first 250 meters, he takes a time of 3 minutes 20 seconds. So he takes a time of 3 minutes 20 seconds. So better we can write it in. So 3 minutes, it's going to be 60 into 3. So 180 plus 20. So that will be 200 seconds. Then here 4 minutes. 4 minutes in the sense 240 seconds. But in between, here he stops for a while and he took a time of 1 minute. 1 minute means 60 seconds of time. Hope it's clear for you, right? So keep this in mind. It's a very interesting question. When we are calculating average speed, we have to consider the times which you have stopped also into the consideration. Okay, so you have stopped in between and you took a time of 60 seconds to relax or whatever. So it means when you're calculating the average speed in this particular case, what we are going to get? Average speed, as I told you, total distance by total time. So this is an important formula for you. Total distance by total time. So how much is the total distance here? 250 plus 250, that will be 500 meters. And how much is the total time here? 300 plus 200, that's going to be 500 seconds. So the answer is very clear. It is 1 meter per second. Understood? So option 1 is the answer. Hope it's clear. Option 1 is the answer for this objective question. So always remember, when you're calculating average speed, you are not calculating the speed at a particular instant. You are calculating the overall rapidity, how rapidly the object has moved, and how you can do that. That you can do by finding average speed. That's nothing but the total distance by total time, and that will be 1 meter per. So what is instantaneous speed and what is the difference between instantaneous speed and average speed? So instantaneous speed is basically, it's a speed at a particular instant. Okay, so it is just a speed of any particular object at a particular instant. It means, suppose, let's say if an object is traveling, okay, for a long period of time, okay, so there is a long period of time, there is a time interval, right? So some t equals 0 to t equals to t, then we will get an average speed in this particular case, right? So we will obtain what? Average speed here. But if the particle is traveling, like if you want to know the speed at this particular point, so it means we are calculating the speed of the object, okay, speed at this instant, right? So what you need to do, so to find the speed at a particular instant, your time interval should be small, right? So your time interval should be very small, right? So when you make your time interval very small, like short duration of time, right? So that particular situation is basically known as the instant, right? So if you measure, let's say the car travels, okay, 20 meters in 0.1 second, right? So you are actually getting its average instantaneous speed, okay? So here you are basically getting the instantaneous speed, right? So average speed is basically you are finding the total overall rapidity or overall rate at which the object is moving. But when it comes to instantaneous speed, you are simply finding the speed at a particular moment, okay? So suppose if you apply brakes, what happens? The speed of the car will be suddenly 0, right? So that is the speed at that instant, understand, right? So that's what is about instantaneous speed. So a car travels 20 meters in 0.1 second. So what will be the instantaneous speed here? It will be distance by time, right? So that will be 200 meters per second, right? So 200 meters per second is the speed of the car at that particular instant in this time interval of 0.1 second somewhere, okay? So this is what about instantaneous speed means. This is the speed at a particular instant or speed at a particular moment. Hope it's clear, right? Let's look into average velocity. So what is average velocity? Average velocity is nothing but total displacement upon total time taken, right? So it's displacement covered in a time t. How much displacement the object traveled divided by the time taken. That's nothing but average velocity. So average velocity is a vector quantity, right? Average speed is a scalar quantity. Average velocity has a direction, but average speed doesn't have any direction. It's just a magnitude. And average velocity is also measured in kilometer per hour or meter per second. If I want to say average velocity of a car moving in a certain direction, I need to mention its direction also because it's average velocity. If I say a car is having an average velocity of 20 km per hour, I had to mention 20 km per hour towards north, or towards east, or towards west, or towards south. So something I had to mention when it comes to average velocity. I should say average velocity of a car is, for example, 30 km per hour towards northeast. Right? So this is also one more way to express average velocity, because it's a vector quantity. It's a vector quantity. Hope it's clear. So that's the thing about average velocity. Why the average speed is always greater than average velocity? Because the average speed is given by total distance by time, but when it comes to average velocity, it is total displacement by time. So that's the reason your average speed would be greater than average velocity when you consider between any 2 points during the journey of a particular object, right? So our average speed could be equal to average velocity when it's moving on a straight line, okay, without changing the direction. In that case, both could be equal. Okay, so it's not must be equal, but it could be equal or greater than average velocity. Average speed might be equal or greater than the average velocity, okay, but it's not less. So similarly, average velocity is definitely less than or equal to average speed. It can't be more than average speed. Why? Because it's a vector quantity and it's given by displacement by time. And we know the displacement is always less than or equal to distance. Right? When you travel between any 2 points, distance is always greater than or equal to displacement. So that's the reason average speed is greater than or equals to average velocity. Object. So basically, velocity is nothing but the rate of change of displacement, right? So velocity is basically the rate of change of displacement. So it is the velocity is a rate of change of displacement, right? So here for a basic understanding, what you can see here is generally if you travel a displacement, if you cover some displacement in a very small time interval, okay, so if you cover a car displacement of 10 meters towards north in let's say 0.2 seconds. So what is its velocity or instantaneous velocity? That will be 10 divided by 0.2, right? So that will be 100 by 2, that is 50 meters per second towards north. So this is a way where you can find the instantaneous velocity, or simply known as velocity, right? So for basic understanding, we can see here velocity is simply average velocity, you know, right? It's a total displacement by total time. So total time means it's a very long time interval. But when it comes to instantaneous velocity, it is the velocity at a particular instant. So you have to mention along with the direction also. Okay, so that is the thing about instantaneous velocity, right? So you have to mention along with the direction as well. Let us see one interesting question on this. Look into this question. Given that Usha swims in a 90-meter long pool, she covers 180 meters in 1 minute by swimming from one end to the other and back along the same straight path. Find the average speed and average velocity of Usha. As you can see here, she swims in a pool, right? 90-meter long pool. Okay, so she covers 180 meters in 1 minute by swimming from one end to the other and back along the same straight path. Okay, so it means she moved like this and again she moved back. So she started from here and she reached there itself. You can see what is the difference you are going to get here. Average speed, when you try to calculate, it is the total distance, total time, right? So moved forward by 90 meters and then moved back by 90 meters. So total 180 meters in a time of 1 minute. 1 minute means 60 seconds. So that means it is 3 meters per second is the average speed over here. But when you try to calculate average velocity, it's a vector quantity, it has a direction. Average velocity, what happens here? Average velocity is total, it's a displacement by total time. So when you look at the total displacement, what happens to total displacement? Total displacement is 0. Why? Because she moved forward and then again she moved back to the same position. So the displacement is 0, right? So that's why average velocity is also 0 here.